सोलर चार्ज कंट्रोलर और ये स्पेसिफिकली यहाँ पे लोकली पाकिस्तान में बना रहे हैं। और मैं रिक्वेस्ट करूँगा इंजीनियर साहब से कि काइंडली स्टेज पे आएँ और अपना प्रेजेंटेशन हमें दें। थैंक यू।
It's a unique MPPT solar charge controller and with a very special features that I would like to elaborate. First of all, a little background. As you can see in this map, Pakistan has very large solar installation, especially in the province of Sindh, Balochistan and Punjab. So in the table you can see that the daily production of PV is 4.3 kilowatt hours per kilowatt of installed capacity. That's a rough average, and this is considered very good by international standards. Then in Pakistan we have a large lower middle class population, and of course as everyone knows, they are very much disturbed by the rising cost of electricity, and even though they receive electricity at a lower subsidized rate, but still it has become unaffordable for them. Then here there is some good news. In the graph, as you can see, the price of solar panels has decreased from rupees 90 per watt down to rupees 40 per watt in less than a year. So this has never happened before, and it is good news for the lower middle class, and it has brought the PV generation, solar generation into the range, in their range. However, there is one issue that the prices of inverters, hybrid inverters and on-grid inverters, it has actually risen quite even more than it was before. So it is completely out of reach of their reach. Now the solution is that all these middle class people, most of them have UPSs already in their homes, and they have problems in battery charging, people load shedding, voltage issues, etc. So they have started giving up on them, but with these low prices, they can have a unique type of hybrid system, which is an on-off hybrid system, and DC system as a viable alternative. Now I am given a brief intro about solar charge controller. What is a solar charge controller? It takes power from the PV panel and charges the batteries, and it controls the flow of power so as to ensure safe and long life of the battery. It is usually done in three stages, like bulk charge, absorption charge and float charge. So it maintains this so as to maintain the life and health of the battery. Also, it has over discharge protection, so that in case there is more consumption than there is production, then it cuts off the load, so as to protect the battery from being damaged. Then we have the PWM charge controller. Now these PWM charge controllers, they drop the PV voltage down to the battery voltage. So what happens is that it wastes all the extra energy, because normally the PV voltage is higher than the battery voltage. So all that extra power that is there is wasted, and it is significant to 25% of the power, and this is a big loss. Then also it causes heating in the solar panel, because all that extra power is actually wasted in these solar panels, further degrades them. However, these charge controllers are low cost and quite widely used even these days. Now the MPPT charge controller has a DC to DC converter built in. So what it does is that it takes the higher voltage of the solar panels and using DC-DC conversion steps it down to lower voltage of the battery. So the extra power that was available due to the high voltage is utilized and as increased current in the battery is available from the panels. So also it runs the maximum power point algorithm, MPPT algorithm, so that loads the panel down to its maximum power point so as to get maximum benefit out of it. Then we have also the advantage that you can use higher voltage panels to charge a lower voltage battery. For example, these panels these days have an MPP
सर मैं रिक्वेस्ट करूंगा कि थोड़ा सा नॉइज कम करें बैकएंड पे अगर कुछ लोग बात करना चाह रहे हैं तो बाहर जा सकते हैं प्लीज तो रिक्वेस्ट है कि काइंडली डेकोरम का ख्याल रखें थैंक यू
Well, most of the panels, the high power panels are 50 volt DOC and the batteries mostly used are 12 volt. So it can easily convert the higher panel and you use them for the lower voltage battery. Then again, another advantage is that you can connect the panels in series so as to reduce the current in the PV line and get and you of course reduces dia and cost. Now this is a unique condition in Pakistan that is being widely used. It is called a hybrid function in a charge controller. How it is done is that since most of those people have already have a UPS in their home, what they do is connect the PV panel to the charge controller and then connect the battery directly to the connect the charge controller directly to the battery and connect the UPS also to the battery. So that way both are connected and the input phase of the utility power is connected via the hybrid switch into the UPS. Now, when the solar power is available, the charge controller automatically cuts off the hybrid switch and the UPS converts to inverter mode and it starts running. So, in that mode, the power from the solar is utilized by the load and the customer can use it. Whenever the solar power, there is a shortfall in solar power, the battery voltage starts dropping and then the switch is closed and the UPS converts to base power and then the load is powered directly by the AC utility supply. So this is actually a very low cost solution and it is very well affordable for lower middle class people. It has the disadvantage that it has some cycling of the battery, but that's you have to live with that. Then Systek has introduced these Smart MPPT charge controller new models, and they are a step ahead of those available in the market, and they have no competition right now. The main difference between a normal MPPT charge controller and our charge controller is the features. First of all, we have the innovative MPPT algorithm, the innovative and the high efficiency operation. It is designed specifically for lesser losses. Then we have a three-stage charging, which is of course a necessity. And we have low coincident current to reduce load on the battery while it is not being used. Then in the further design and flexibility features, we have a wide range of models so as to select the appropriate one for the consumer. And we have hybrid and as well as DC modes available. And auto battery sensing is that the same charge controller can be connected to a 12 volt battery, 24 volt battery, 36 volt battery, or even a 48 volt battery, and it automatically adjusts itself whatever. So this gives added flexibility not only to the end user but also to the resellers, because they don't need to stock all the different models separate. Then we have a wide panel voltage, so that gives flexibility for in panel selection because it accepts a wide range of voltages at the end. And finally we have the parallel operation feature. This is usually available in very expensive hybrid inverters, etc. Here, if the customer wants to increase the capacity, then he can simply add another charge controller and another set of panels on it, and both the panels run in synchronism so as to coordinate with each other. So besides another, it has two more uses. Sometimes the customer has one type of panels, but usually those type of panels will not be available when the customer upgrades wants to add more panels. So now he can just add another charge controller, and both the panels, both the sets of panels can run on their own optimal MPP point. So that way you can get maximum benefit out of your panels. No need to dispose of the old panels to get the power. And another feature of this parallelability is that with multiple MPPT, sometimes the customers have shading problems. So they can connect the shading panels on one MPP charge controller and those without shading on another charge controller. And that way the shading of one of the panel will not affect the efficiency of those who are still not shaded. Similarly, we have convenience and control. We have a DC output option that can be switched on and off manually. In case user wants to switch off all load, it can do so. Besides, another feature is that even the panel can be switched on and off manually. This is not available in other charging. The advantage this gives is that you can eliminate the input breaker on these small systems because the price of a DC breaker even for a small system is significant for the end user. So we have written this option to eliminate it. So even when you are doing any servicing maintenance, you can switch off the panel from the system and check it out. Similarly, we have automatic night light mode also. This is used where the charge controller is meant for solar lighting. So the DC load output, it switches off automatically in the day and switches on automatically at night. So when this mode is activated, so it can be used for outdoor lighting and street lights, etc. Then we have user interface, an LCD-based user-friendly interface that shows all the parameters and you can check them out.
Sorry to interrupt, please conclude.
Correct. Then we have two LEDs display, and also all the parameters of the charge control can be set manually by the user. All the can be adjusted. Similarly, we have protection and durability. It has all types of short circuit and protections and reverse battery and reverse panels protections. And then an important feature is that it is a fanless design. Now, fan is a weak component in any electronic system, and so we have eliminated the fan. So also it has no vents. So even in the dusty environment of Pakistan, it is very good and gives long service life. And our casing is IP54 casing. That is, with the sand splashes from rain, etc. for greater reliability. Finally, we have the connectivity. We have a Wi-Fi interface option that can be used for remote monitoring. And the Wi-Fi interface, we have designed it such that you don't need an app. It is browser based, so you no need to install an app. Also, we have data logging on remote servers. For example, if someone has many charge control installed over a wide area, then he can get a logging of the data on a central server and monitor the performance of all charge control from a single place. And also we have external Wi-Fi option, where if the charge controller is installed at a place where the Wi-Fi signal is weak, then they can use an external Wi-Fi device and connect it to the charge controller. I think that covers it all. Thank you very much.
Thank you.